Yeah, we're moving on to our final group of lessons. We're going to talk about 3D figures. We're going to talk about surface area and volume. And we'll start today with two shapes, the cylinder and the cone. So a cylinder has two important dimensions, the height and the radius. And a cylinder has two bases, and both of those bases are circles. And the radius is always from the base, and the height is the distance between the two bases. So height in this case is not always up and down. If this cylinder was turned on its side, the height would still be 7 because it would be the distance between the top circle and the bottom circle. And we have these formulas, and these formulas will be provided for you on a formula sheet for the SOL or any quiz that we take. So you don't really need to memorize them, but you need to know how to work with them. And you need to know that R means the radius of the base, and H means the distance between the two bases or the two circles of the cylinder. So if you want to do an example where we're finding these three values, and I'll say that the lateral area is the area on the surface of the figure not including the two bases, and the surface area is the lateral area plus the two bases. So if we're going to look for the lateral area, that's this sort of like area going up and down. We plug in the radius 2 and the height 10, and then we just compute. 2 times 2 is 4, times 10 is 40, we get 40 pi. If we multiply by pi, we get 125.7. If I want to get the whole surface area, that means adding in the two bases. Again, I'm just plugging in R, the radius 2 for R and 10 for H. I'm computing. I'm going to wait till the end to multiply by pi. So here I get 8 pi plus 40 pi. I can just add those two things and make it 48 pi. If I multiply by pi, I get 150.8. And the volume, again, we're just plugging in R and H. So I plug in 2 for the radius. I plug in 10 for the height, or the distance between. I simplify, and I get 40 pi, or 125.7. So let's do another one. This one is just a little bit tricky because right here I have the diameter of the base, and I need the radius. So my radius is half the diameter, which is going to be 7. So when I'm trying to find the lateral area, I'm plugging in 7 for the radius and 8 for the height. And this is what I get. For the surface area, I'm going to plug in, again, 7 for R, 8 for H. Simplify both of these to get 98 pi plus 112 pi. And then I can answer in either way. And again, volume, plugging in 7 for R, 8 for H, simplify, and that's what we get. So go ahead and try this one. Find the lateral area, the surface area, and the volume. So straightforward, I have the radius of the base is 4, the height, the distance between the two bases is 7. I plug those in for R and H and get 56 pi, or 175.8. For my surface area, again, R is 4, H is 7. It's just about plugging in and making sure we do the appropriate order of operations. So that means doing this 4 squared before I multiply by 2, simplifying all this before I add. And last but not least, my volume is right there. So make sure you check your answer, look at my work, make sure you got the right thing. Cone is similar. The difference between a cone and a cylinder is that a cone has one base. It's still the circle. And we need the radius of the base. The height is the distance from the top of the cone to the base that's perpendicular. So that's why we see we have a right angle here. And then we have this thing called slant height, and that's the distance from the top of the cone down to the base, but along the side of the cone. So this dimension we call slant height. And you might see that the height, the radius, and the slant height make a right triangle here. And we can use Pythagorean theorem if we know two of those measures but not the other one. So when you look at these formulas, again, you'll be given these formulas on a formula sheet. But if you look, you need to know that r is the radius, h is the straight up and down height, and this L, this is an L, it looks like a 1 but it's an L, this L represents the slant height, this dimension right here again. So let's look at an example. In order to do all three of these, lateral area, surface area, and volume, I'm going to need my slant height, so I need to do Pythagorean theorem. I have this right triangle where the slant height is my hypotenuse, so I can do a squared plus b squared equals c squared, and I can solve to get that the slant height is 7.3. And that should make sense because the hypotenuse should be the longest part of the right triangle, and therefore my slant height should be longer than 7 and 2. So now I can just plug in for R and L to get my lateral area. So I plug 2 in for R, 7.3 in for L to get the lateral area. I can plug in R and L for the surface area formula to get my surface area. And these will be in miles, so 58.4 miles, 45.8 miles squared, miles squared, sorry, since it's an area. And my volume, I plug in R, and this time I'm going to use H, this perpendicular distance 7, and I get the volume to be 29.3, and that would be miles cubed. So let's do another one. This time I have the diameter, so my radius is going to be half of that, which is 9. I need to solve for the slant height again, so I use Pythagorean theorem. Plug in 9 my radius and 18 my height, and get the slant height to be 20.1. So then I can just use my values to plug in and get lateral area, surface area, and volume. Again, plugging in 9 for everywhere I see R, plugging in 20.1 everywhere I see L, because that's my slant height, and plugging in 18 because that's my vertical height, my perpendicular height, anywhere I see H, and that is only in the volume formula. So pause here, give this one a try. You're going to have to find this time the vertical height, the perpendicular height. So we use Pythagorean theorem. This time 30, our slant height is C, since the slant height is going to be the longest of the 3 dimensions. And we're looking for A or B, so it doesn't matter which one you choose. So if we solve here for H, we get H to be 27. So this straight up and down distance is 27. So then you can use the formulas. We'll plug in 13 every place we see R. We'll plug in 30 every place we see L, the slant height. And we plug in 27, that dimension we found for H, everywhere we see H, which is only in the volume formula. And these are the values we get. So I've got 2 for you to try. I want you to find all 3 values, lateral area, surface area, and volume for both. I've given you enough places to answer for lateral area, surface area, and volume for both. So do that and submit it on the Google form, and we'll talk about them in class.